Hello there, and welcome to the Mikey Wild Tales. I'm so glad you're here. Maybe the world felt a little too fast today, or maybe you're simply ready to drift off wondering about the invisible rules that hold everything together. Either way, tonight's journey is for you. There's nothing you need to solve right now. Just let your body rest, let your breathing deepen, and let your thoughts float free. Because tonight, we are turning our attention to something purely effortless, light itself. We're going to explore a fascinating paradox. We'll discover why light, which has absolutely zero mass and nothing to weigh it down, cannot go infinitely fast. We will travel through the vacuum of space to understand that this limit isn't about the light, but about the very fabric of space and time. From the stillness of a photon's perspective to the heartbeat of the universe, we'll uncover why this cosmic speed limit is the only thing keeping reality from happening all at once. Some ideas may spark your imagination, while others might just soothe you into a deeper understanding of the cosmos. And if these calm explorations of physics help you rest, feel free to like and subscribe. It helps others find their way to this quiet space, too. Now, if you're ready, let's begin. Picture this scenario in your mind. You are currently gripping a flashlight in your hand. You press down on the button, and a beam of light shoots outward at a velocity of 299,792,458 meters per second. Now, here is the part that is going to bend your mind and shake everything you previously thought you understood about the nature of reality. Light possesses absolutely zero mass. Zero. Nothing at all. It does not weigh a single thing. So, answer this question for me. If light possesses no mass, and if there is literally nothing there to impede its progress, no friction in the depths of space, no air resistance in the vacuum, why does it not travel infinitely fast? Why does it stop at exactly 299,792,458 meters per second? What invisible wall is light crashing into? Think about this concept for a second. When you throw a baseball, it eventually slows down because of air resistance and gravity, both of which act upon its mass. A bullet fired from a gun eventually falls to the ground. It is the same reason: mass. But we are talking about light. Light has no mass. There is nothing for gravity to grab onto in the same way, nothing to slow it down. So why, in the infinite emptiness of the cosmos, does light have a speed limit at all? Here is what is about to blow your mind. The speed of light is not actually about light. The universe has a cosmic speed limit built into the very fabric of space and time itself. And light just happens to be the messenger showing us this fundamental law. Everything you are about to learn will completely change how you perceive reality. By the end of this video, you will understand why you, sitting there right now, can never travel faster than light. You will learn why time itself is negotiable, and why the speed limit of the universe might actually be the only thing preventing reality from completely falling apart. But before we dive deep into this rabbit hole, smash that like button if you are ready to have your mind completely reconstructed. Hit subscribe because we are going deep into physics that will change how you see everything. And drop a comment telling me what country you are watching from and what time it is right now. I want to know where in the world people are having their minds blown. Are you watching this at 2 a.m., unable to sleep? Are you supposed to be working right now? Tell me. I read every single comment. All right, let us start with what seems like a simple question. What is light? And I am going to give you an answer that is going to sound absolutely insane, but is completely true. Light is both a particle and a wave simultaneously. Not sometimes a particle and sometimes a wave. Both at the exact same time. Always. In the year 1905, a 26-year-old patent clerk named Albert Einstein, yes, that Einstein, published a paper that would change everything. He was working in a patent office in Bern, Switzerland, examining patent applications during the day and completely revolutionizing physics at night. This paper explained something called the photoelectric effect, which proved that light comes in discrete packets called photons. These are particles of light. Before Einstein, most scientists thought light was purely a wave, like ripples on a pond. Einstein showed that light hits metal surfaces like tiny bullets, knocking electrons loose. This discovery won him the Nobel Prize in 1921. But here is where it gets weird. Those same photons that act like particles also behave exactly like waves. They create interference patterns. They have wavelengths. They can be diffracted. Thomas Young proved this back in 1801 with his famous double-slit experiment. He shot light through two narrow slits and watched it create an interference pattern on a screen behind it. Light and dark bands that could only be explained if light was a wave interfering with itself. Think of it like this. Imagine you are simultaneously a solid rock and an ocean wave. You are both at the same time. That is what light is. It is a fundamental duality at the heart of reality itself. Now, these photons, these particles of light, have zero rest mass. This was confirmed through countless experiments throughout the 20th century. If photons had even the tiniest amount of mass, our entire understanding of the universe would collapse. GPS satellites would not work. Your smartphone would be useless. The fact that you can stream this video right now is proof that photons have no mass. But here is the twist that is going to set up everything else. Just because photons have no rest mass does not mean they have no energy. In fact, photons have a tremendous amount of energy. Einstein's most famous equation, E equals mc squared, actually has a more complete form. The full equation is E squared equals mc squared squared plus pc squared, where p is momentum. For a photon with zero mass, this simplifies to E equals pc. Photons have energy and momentum despite having no mass. They can push on things. That is why solar sails work in space. Photons from the sun physically push against reflective surfaces. Let me paint you a picture of just how weird this is. Right now, photons from the sun are hitting your skin. They are massless, yet they are pushing on you. The pressure is unimaginably small, about 9 microns per square meter if you are standing in direct sunlight. But it is real. Massless particles are physically pushing on your body. You are being moved by things that have no mass. So, we have established two mind-bending facts. Light is simultaneously a particle and a wave, and it has energy and momentum despite having zero mass. Now, here is where most people's brains start to hurt. If light has no mass and nothing is slowing it down, why does it move at exactly 299,792,458 meters per second? Why that number? Why not 500 million meters per second? Why not infinite? The answer is going to sound like I am dodging the question, but stick with me. Light does not have a speed limit. The universe does. Let me ask you something that seems completely unrelated. What is space? No, seriously. What is the emptiness between objects? Is it just nothing? A void? Here is the truth. It is going to sound like science fiction. Space is something. It is an actual thing. Space has properties, structure, and characteristics. And here is the kicker. Space and time are not separate things. They are woven together into a single fabric called spacetime. This was Einstein again in 1915 with his general theory of relativity. Einstein realized that what we call space and what we call time are actually two aspects of the same thing. You cannot have space without time, and you cannot have time without space. They are fundamentally interconnected, like two sides of the same coin. Think of it like this. Imagine a massive stretched rubber sheet. That is space-time. When you place a bowling ball on the rubber sheet, it creates a depression, a curve in the fabric. That curve is what we experience as gravity. Now imagine rolling a marble across the sheet. The marble's path will curve around the depression created by the bowling ball. That is how planets orbit stars, how moons orbit planets, and how light bends around massive objects. But here is what is crucial. That rubber sheet, spacetime itself, has properties. It is not infinitely stretchy. It has resistance. It has structure. And one of its fundamental properties is that it has a maximum speed at which information, energy, or matter can propagate through it. That speed is 299,792,458 meters per second. Light does not travel at the speed of light because of anything special about light itself. Light travels at the speed of light because light has no mass, and anything with no mass automatically travels at the maximum speed that spacetime allows. The speed of light is actually the speed of causality itself. It is the maximum speed at which cause can lead to effect anywhere in the universe. Let me blow your mind with this. If we discovered tomorrow that photons actually do have a tiny, tiny amount of mass, so small we cannot currently measure it, light would travel slightly slower than it does now, but the universal speed limit would remain exactly the same. That limit is a property of spacetime itself, not of light. In 1987, astronomers observed a supernova, an exploding star in a nearby galaxy called the Large Magellanic Cloud, about 168,000 light-years away. This supernova, designated SN 1987A, released an unimaginable amount of energy in multiple forms: light, neutrinos, and gravitational waves. Scientists detected both the light and the neutrinos from this explosion. Here is what is remarkable. They arrived at Earth at almost exactly the same time after traveling for 168,000 years through space. Neutrinos have a tiny amount of mass. We have measured it. But they arrived at virtually the same moment as the photons. Why? Because both were traveling at nearly the maximum speed allowed by spacetime. The photons, having no mass, traveled at exactly the cosmic speed limit. The neutrinos, having a tiny mass, traveled at just slightly below that limit, so close that over 168,000 years, they only fell behind by a few hours. This experiment proves something profound. The speed limit is not about the particles. It is about the universe itself. But why? Why does spacetime have this property? Why 299,792,458 meters per second, and not some other number? Here is where we need to talk about something that sounds abstract, but is actually the most concrete thing in physics: the structure of spacetime itself. And to understand this, we need to go back to 1864, to a Scottish physicist named James Clerk Maxwell. Maxwell was obsessed with electricity and magnetism. Scientists at the time knew these were related. Move a magnet near a wire, and you get an electrical current. Run electricity through a wire, and you create a magnetic field. But no one understood why. Maxwell did something revolutionary. He wrote down 4 equations, now called Maxwell's equations, that completely described how electric and magnetic fields interact. When he manipulated these equations mathematically, something extraordinary fell out of the math. The equations predicted that oscillating electric and magnetic fields could create waves that would propagate through space. And when Maxwell calculated how fast these electromagnetic waves would travel, he got a number: approximately 300,000 kilometers per second. He realized with shock that was the speed of light. Light was an electromagnetic wave. But here is what is crucial. The speed of light fell out of the equations naturally. It was determined by 2 constants that appear in Maxwell's equations: the permittivity of free space and the permeability of free space. These are properties of the vacuum itself, of empty spacetime. The speed of light is literally baked into the fabric of reality at the most fundamental level. Think of it like this. Imagine spacetime is like a crystalline structure, like a diamond. The atoms in a diamond are arranged in a specific pattern, and that pattern determines how fast sound waves can travel through the diamond. The speed is not arbitrary. It is determined by the structure itself. Spacetime is similar. It has an inherent structure, and that structure determines the maximum speed at which anything can propagate through it. But why does having mass slow you down? Why can only massless particles reach the cosmic speed limit? Here is the answer, and it is going to sound bizarre. The faster you move through space, the slower you move through time. And the cosmic speed limit is the point at which you would stop moving through time entirely and only move through space. Let me explain this carefully because it is crucial. You are always moving through space-time at the same total speed. Always. Right now, sitting still, you are moving through time at maximum speed, 1 second per second. But you are barely moving through space. When you start moving through space, say by standing up and walking, you start moving through time slightly slower. The faster you move through space, the slower you move through time. This is not theoretical. We have measured it. In 1971, physicists Joseph Haffel and Richard Keating took 4 atomic clocks on airplane flights around the world. When they compared the clocks to identical clocks that stayed on the ground, the flying clocks showed less time had passed. The clocks that moved through space faster experienced less time. GPS satellites orbiting Earth experience this effect constantly. They are moving fast enough that time passes differently for them than for us on the ground. If we did not account for time dilation in GPS satellites, your navigation would be off by kilometers. The fact that GPS works is daily proof that moving through space slows your movement through time. Now, here is the key. As you approach the speed of light, time dilation becomes extreme. At 90% the speed of light, time passes about half as fast. At 99.9% the speed of light, time slows to a crawl. At exactly the speed of light, time stops completely. Photons do not experience time. From a photon's perspective, if it had a perspective, it is emitted and absorbed in the same instant. A photon that travels from a distant galaxy, journeying for billions of years from our perspective, experiences no time at all. The moment of its creation and the moment of its destruction are the same moment for the photon. This is why only massless particles can travel at light speed. Because traveling at light speed means not moving through time at all. You would exist at every point along your path simultaneously, and that is only possible if you have no mass. But now we need to address the elephant in the room. Why does having mass prevent you from reaching light speed? What is it about mass that slows things down? The answer is going to reshape your understanding of what mass actually is. Mass is not stuff. Mass is energy. They are the same thing. E equals mc squared is not just a cute equation. It is a profound statement about the nature of reality. Mass and energy are completely interchangeable. They are two forms of the same fundamental thing. When you try to accelerate an object, say push a car, you are adding energy to it. That energy has to go somewhere. For slow speeds, it goes into the car's motion, its kinetic energy. But as you approach the speed of light, something weird happens. The energy you add does not just make the car go faster, it makes the car more massive. This was proven definitively at particle accelerators like CERN in Switzerland. When physicists accelerate protons to 99.999991%, the speed of light in the Large Hadron Collider, those protons become about 7,460 times more massive than they are at rest. The energy pumped into them is converted into mass. The faster they go, the more massive they become, and the harder it is to accelerate them further. To accelerate any object with mass to exactly the speed of light would require infinite energy. Not just a lot of energy. Infinite energy. It is impossible. The universe will not allow it. Here is an analogy. Imagine trying to push a car through increasingly thick molasses. The faster you try to go, the thicker the molasses becomes. At some point, the molasses becomes infinitely thick, and you simply cannot push through it no matter how hard you try. That is what accelerating to light speed is like. The molasses is the energy converting into mass. But photons have no mass. They never need to be accelerated to light speed. They are created traveling at light speed. A photon does not start slow and speed up. It pops into existence, already moving at 299,792,458 meters per second. And because it has no mass, no energy is needed to maintain that speed. Think about that for a moment. Every photon ever created, from the Big Bang to the light bulb you turned on this morning, was born traveling at the same speed. That speed is a fundamental property of spacetime itself. Now, here is something that is going to twist your brain. Light actually does slow down when traveling through materials like water or glass. The speed of light in a vacuum is 299,792,458 meters per second. But in water, light travels at only about 225 million meters per second. In diamond, light crawls along at a mere 124 million meters per second. Why? Are photons suddenly developing mass? No. Here is what is actually happening. When light enters a material, the photons interact with the electrons in the atoms of that material. A photon gets absorbed by an electron, which jumps to a higher energy state, then drops back down and re-emits a new photon. This process happens over and over, billions of times per second as light travels through the material. Each individual photon still travels at exactly 299,792,458 meters per second in the tiny gaps between atoms. But the constant absorption and re-emission process creates a delay, making the overall progress of light through the material slower. The photons themselves never slow down. They are always traveling at c, the cosmic speed limit. But the zigzag path they take through matter creates the illusion of slower travel. Let me ask you something that might seem to have an obvious answer. Does light have a color? Is red light different from blue light at a fundamental level? The answer is yes, but in a way that reveals something profound about the relationship between energy, frequency, and the speed of light. All electromagnetic waves travel at the same speed in a vacuum, c, but they can have different wavelengths and frequencies. Red light has a longer wavelength and lower frequency than blue light. Blue light has more energy per photon than red light. Here is the equation that connects them all. C equals lambda f, where c is the speed of light, lambda is the wavelength, and f is the frequency. This equation tells us something remarkable. Because c is constant, wavelength and frequency are locked in an inverse relationship. If you decrease the wavelength, the frequency must increase to keep the product equal to c. The speed remains constant, but the energy changes. A radio wave and a gamma ray are both electromagnetic radiation. Both are light in a general sense, traveling at exactly the same speed. But a gamma ray has a wavelength millions of times shorter than a radio wave, which means its frequency is millions of times higher, which means each gamma ray photon carries millions of times more energy. In 1900, a German physicist named Max Planck discovered that electromagnetic energy comes in discrete packets proportional to frequency. The energy of a photon is E equals hf, where h is Planck's constant and f is frequency. This discovery laid the foundation for quantum mechanics. What this means is profound. The speed of light is constant, but the energy light carries can vary enormously. The universe has a speed limit, but no energy limit for individual photons. In fact, we have detected photons with such high energy they defy easy explanation. In 1991, a cosmic ray observatory in Utah detected a particle, likely a photon or high-energy proton, with an energy of about 50 joules. That might not sound like much, but remember, this is a single subatomic particle. To put it in perspective, that is about the same kinetic energy as a baseball thrown at 60 miles per hour, except contained in something smaller than an atom. These ultra-high-energy cosmic rays are still traveling at the speed of light, or infinitesimally close to it. The speed does not change. The energy does. Now, let us talk about something that is going to make you question everything you thought you understood about reality. Relativity. Not just the fact that time slows down when you move fast. We have covered that. I am talking about something more profound. There is no such thing as absolute motion or absolute rest. Everything is relative. Here is what I mean. Imagine you are sitting on a train that is moving at 100 kilometers per hour. You throw a ball forward at 20 kilometers per hour relative to you. How fast is the ball moving? You would think 100 plus 20 equals 120 kilometers per hour relative to the ground, right? That is correct for slow speeds. But here is where reality gets weird. It does not work that way for light. Imagine you are on a spaceship moving at 50% the speed of light. You shine a flashlight forward. How fast is the light moving? You would think 0.5 c plus 1 c equals 1.5 c, right? Light speed plus half light speed equals 1.5 times light speed. No. The light is moving at exactly c, 299,792,458 meters per second. Both from your perspective on the spaceship and from the perspective of someone watching you fly by. The speed of light is the same in all reference frames. This makes no intuitive sense. It violates everything about how we experience reality. But it is absolutely true, and it has been verified by countless experiments. In 1887, Two American scientists, Albert Michelson and Edward Morley, conducted an experiment that would change physics forever. They were trying to detect the luminiferous ether, a hypothetical medium through which light was thought to propagate, like sound waves propagate through air. Their reasoning was simple. If Earth is moving through this ether as it orbits the Sun, then light should move faster when traveling in the direction of Earth's motion and slower when traveling against it. Just like throwing a ball forward on a moving train. They built an incredibly sensitive interferometer, a device that splits a beam of light, sends the two beams in perpendicular directions, then recombines them. If one beam was traveling with the ether and one against it, the difference in speed would create an interference pattern. They found nothing. No difference. No matter which direction they measured, light traveled at exactly the same speed. This result was so perplexing that it created a crisis in physics. It meant either that the ether did not exist, or that something very strange was happening with space and time themselves. Einstein resolved the crisis in 1905 with his special theory of relativity. He made two simple postulates. First, the laws of physics are the same in all inertial reference frames, frames moving at constant velocity. Second, the speed of light is constant in all inertial reference frames. From these two simple assumptions, everything else follows. Time dilation, length contraction, the relativity of simultaneity, mass-energy equivalence, all of it cascades from the constancy of light speed. But here is what this really means. And this is going to sound insane. When you are moving fast relative to someone else, you are literally experiencing a different passage of time. It is not an illusion or a measurement error. Time actually passes differently for you than for them. In 2014, physicist Ronald Mallet proposed a theoretical design for a time machine based on rotating light beams. The idea exploits the fact that massive rotating objects drag spacetime around them, an effect called frame dragging. Mallet's hypothesis is that an intense rotating beam of light could create a similar effect, potentially allowing for closed time-like curves, paths through spacetime that loop back on themselves, theoretically enabling time travel. Is it possible? We do not know. The energy requirements would be astronomical. But the fact that serious physicists can propose such ideas based on the properties of light and spacetime tells you how strange the universe really is. Let us go deeper. I want to talk about something that happens at the intersection of quantum mechanics and relativity. Something that is going to completely shatter your intuitions about reality. Quantum entanglement and the speed of light. In the quantum world, particles can become entangled, connected in such a way that measuring one particle instantaneously affects the other, no matter how far apart they are. Einstein called this spooky action at a distance because he hated it. It seemed to violate the cosmic speed limit. Here is how it works. Imagine you create two photons in a special quantum state where they are entangled. You send one photon to Earth and one to Mars. When you measure a property of the photon on Earth, say its polarization, the photon on Mars instantly knows what you measured and takes on the complementary state. This happens faster than light could travel between Earth and Mars. It seems to violate everything we have discussed about the speed of light being the cosmic speed limit. So, what gives? Is information traveling faster than light? No. And this is crucial. No information is actually transmitted through entanglement. The correlation between the particles is instant, but you cannot use that correlation to send a message. The person on Mars sees random results when they measure their photon. Only when you compare your results afterward through normal, slower-than-light communication Do you discover the correlation? It is like having two coins that are quantum entangled. When you flip yours and get heads, the other coin instantly becomes tails, even if it is on the other side of the galaxy. But the person holding that coin just sees tails. They do not know you got heads. They cannot receive information from you through the entanglement alone. The cosmic speed limit is preserved because the speed limit is really about causality, about cause and effect. Entanglement does not allow you to send a signal to make something happen faster than light. In 2015, physicists performed what is called a loophole-free Bell test that definitively proved quantum entanglement is real. This experiment, conducted simultaneously by teams in the Netherlands and Austria, closed all possible ways the correlations could be explained by hidden local variables or communication between the particles. The conclusion is inescapable. Quantum entanglement is a real feature of the universe, and it exists alongside the cosmic speed limit without contradiction. But here is what should blow your mind. Entanglement shows us that the universe is fundamentally non-local. Things that are separated in space can be connected in ways that do not involve anything traveling through the space between them. The universe is woven together at a level deeper than space itself. Let me hit you with something that is going to sound like pure science fiction, but is absolutely real. Nothing can travel faster than light except space itself. Wait, what? The expansion of the universe is not matter moving through space. It is space itself expanding, and there is no speed limit on that. In 1929, astronomer Edwin Hubble, yes, the Hubble Space Telescope is named after him, discovered that distant galaxies are moving away from us. Moreover, the farther away a galaxy is, the faster it is receding. This led to the realization that the universe is expanding. But here is the key insight. The galaxies are not moving through space. The space between the galaxies is growing. It is like blowing up a balloon with dots drawn on it. The dots get farther apart, not because they are moving across the surface, but because the surface itself is stretching. Because it is space itself expanding, there is no violation of the cosmic speed limit. Galaxies that are sufficiently far away are receding from us faster than the speed of light. In fact, there is a boundary called the cosmological horizon, currently about 46.5 billion light-years away, beyond which galaxies are receding so fast that their light will never reach us. Ever. Even though the universe is only 13.8 billion years old, the observable universe is much larger because space has been expanding the whole time. This means there are parts of the universe we will never see, not because light is too slow, but because space is expanding too fast. Those regions are causally disconnected from us forever. In 1998, astronomers made a shocking discovery. The expansion of the universe is accelerating. Something they call dark energy, though we have no idea what it actually is pushing space to expand faster and faster. This discovery won the 2011 Nobel Prize in Physics for Saul Perlmutter, Brian Schmidt, and Adam Rees. If this acceleration continues, eventually every galaxy beyond our local group will recede faster than light. The universe will become dark. Future astronomers trillions of years from now would see only the stars in their own galaxy. They would have no evidence that the universe was ever expanding, no evidence of the Big Bang, no evidence of the billions of other galaxies we can see. The observable universe will shrink even as the actual universe continues to expand. Think about that. Because of the expansion of space, which can exceed the speed of light, Future civilizations will be cut off from the history of the cosmos. They will live in a dark universe, unaware of its true nature. And here is the final twist on this. If you could somehow survive until the heat death of the universe, you would see something remarkable. Photons from distant galaxies. Photons that have been traveling toward us for billions of years will still be arriving, redshifted almost into nothingness, stretched by the expansion of space until they are barely detectable. The light from the early universe is still coming, even as the universe dies. The speed of light is constant, but the universe is playing tricks with the stage on which light moves. Now I want to take a detour that is going to seem strange, but trust me, it connects. Let us talk about something called Cherenkov radiation, and it is going to show you that light can, in a sense, be exceeded in speed. Remember how I said light slows down when traveling through materials like water? In water, light travels at about 225 million meters per second. Now, what happens if you have a charged particle, say an electron, that is moving faster than 225 million meters per second through water? The particle is moving faster than light is moving through that medium. And when that happens, something beautiful occurs. The particle creates a shock wave of light called Cherenkov radiation. It is the optical equivalent of a sonic boom. Think of it like this. When a jet breaks the sound barrier, it creates a sonic boom because it is moving faster than sound waves can propagate through air. The pressure waves pile up and create a shock wave. Cherenkov radiation is the same thing, but with light. This creates a distinctive blue glow. If you have ever seen pictures of nuclear reactors underwater, that eerie blue glow is Cherenkov radiation from high-speed particles moving through water faster than light can. Russian physicist Pavel Cherenkov discovered this effect in 1934 while studying radioactive materials in water. The observation won him the Nobel Prize in Physics in 1958, shared with Igor Tamm and Ilya Frank, who provided the theoretical explanation. But here is the key. Even though the particle is moving faster than light in water, it is not moving faster than the speed of light in a vacuum. It is not violating the cosmic speed limit. The particle is just moving faster than light moves through that particular medium. This shows something subtle but important. When we talk about the speed of light as the cosmic speed limit, we are specifically talking about the speed of light in a vacuum. See, that is the fundamental limit. In materials, light slows down due to interactions with matter. But the ultimate speed limit of the universe remains unchanged. You might wonder, could we create some exotic form of matter that slows light down so much that we could easily move faster than light through it? Could we beat light that way? Technically, yes. We already do in many materials, but you are not beating the cosmic speed limit. You are just moving faster than photons that are playing a very slow game of pinball through a dense medium. In 1999, physicist Len Hao managed to slow light down to just 17 meters per second, about 38 miles per hour, slower than highway traffic, by passing it through a Bose-Einstein condensate cooled to nearly absolute zero. In 2001, she and her team actually stopped light completely, holding it frozen in place, then released it to continue on its way. But even in these extreme cases, individual photons in the gaps between atoms are still moving at c. The overall wavefront is delayed by the constant interaction with matter. Let me now connect this to something personal, something that affects you directly right now. The speed of light is not just an abstract physics concept. It is the reason you exist. It is the reason the universe has structure. It is the reason cause and effect work. It is the reason you can have coherent thoughts and memories. Think about this. Every single chemical reaction in your body, every neuron firing in your brain right now as you process these words, is governed by electromagnetic forces between atoms and molecules. Those forces are mediated by photons, by light. The speed at which these photons propagate determines how fast chemical reactions can happen. If the speed of light were infinite, if there were no cosmic speed limit, cause and effect would break down. Everything would affect everything else instantly. There would be no time lag between cause and effect. The universe would collapse into a single instant of existence. Past, present, and future would be meaningless. The finite speed of light creates the arrow of time. It creates causality. It creates the sequential nature of reality. Moreover, the speed of light determines the structure of atoms themselves. The electromagnetic force between electrons and protons has a characteristic speed, the speed of light. If light moved at a different speed, the balance of forces in atoms would change. Atoms might not be stable. The chemistry that makes life possible might not exist. In 1999, physicist John Webb discovered something shocking. Observations of distant quasars suggested that the fine structure constant, a fundamental constant that determines the strength of the electromagnetic force, might have been slightly different in the early universe. If confirmed, this would mean the speed of light or other fundamental constants have changed over cosmic time. The implications are staggering. If fundamental constants can change, then the laws of physics are not truly universal or eternal. The universe might have gone through different phases with different physical laws. The speed limit we observe now might not have always been the speed limit. However, subsequent studies have been mixed. Some confirm Webb's results, others contradict them. As of now, we do not know for sure if the constants have changed. But the mere possibility reshapes our understanding of what we mean by fundamental law. Here is what I want you to understand. You are a consequence of the cosmic speed limit. Your brain works because of the finite speed of light. Your memories exist because the speed of light creates a causal structure to the universe. If light were infinitely fast, you could not exist. Not just because atoms would not work, but because the very concept of you as a persistent entity with a history would not make sense. The speed limit of the universe is what allows the universe to have a story. It is what allows anything to happen in sequence. It is what allows change, evolution, life, consciousness. You are made possible by the fact that light cannot go infinitely fast. Let us push even further into strangeness. I want to talk about something called the holographic principle and how it relates to the speed of light in a way that is going to fundamentally alter your conception of reality. In the 1990s, physicists studying black holes realized something bizarre. The amount of information that can be stored in a region of space is not proportional to its volume. It is proportional to its surface area. Specifically, to the surface area measured in units of 1 Planck length squared per bit of information. This is called the holographic principle, developed primarily by Gerard 't Hooft and Leonard Susskind. The idea is that our three-dimensional reality might actually be encoded on a two-dimensional surface, like a hologram. What does this have to do with the speed of light? Everything. The holographic principle arises from trying to understand what happens at black hole event horizons, the surfaces from which not even light can escape. The physics of event horizons, the speed of light, and the fundamental nature of information in the universe are all intimately connected. Here is the mind-bending part. If the holographic principle is true, then the three-dimensional world you experience, The depth, the volume, the space you move through might be an illusion. The fundamental reality might be a two-dimensional surface. And our three-dimensional experience is a projection from that surface. And the speed of light? It might be the rate at which information can propagate across that fundamental two-dimensional surface. Think of it like this. Imagine reality is like a computer screen. The screen is two-dimensional, but it can display a three-dimensional game world. You, playing the game, experience the world as three-dimensional, but fundamentally everything is actually happening on a two-dimensional grid of pixels. The speed of light would be like the maximum frame rate, the fastest rate at which the pixels can update. This is not just wild speculation. The holographic principle has been used to successfully solve problems in quantum gravity and has connections to string theory. It is a serious idea in theoretical physics. If it is true, then when we ask, why does light have a speed limit? We might be asking the wrong question. The real question might be, what is the maximum rate at which reality can update itself? The speed of light might not be about light at all. It might be about the computational speed of the universe itself. The rate at which the fundamental substrate of reality can process information and update the state of existence. In 2015, physicist James Gates and others began investigating whether we could detect signs that we are living in a simulation, essentially a highly advanced computer program. One telltale sign would be if there were fundamental limits that looked like computational constraints rather than natural laws. The speed of light could be such a constraint, a maximum processing speed for the hardware running our reality. I am not saying we definitely live in a simulation, but the fact that the universe has a maximum speed limit that applies to everything, information, energy, causality itself, does make reality look suspiciously like a system with computational constraints. And here is something that will really bake your brain. If the universe is fundamentally information-based, then the speed of light is the speed at which the universe can think. Every interaction, every particle collision, every quantum fluctuation is a form of information processing. The cosmos is computing itself into existence one Planck time at a time, and it cannot go faster than c. Now, let us talk about something that seems to violate everything we have discussed: quantum tunneling. This is where particles do something that looks impossible. They pass through barriers they should not be able to penetrate, and they do it in a way that seems faster than light. Here is how it works. In quantum mechanics, particles do not have definite positions until they are measured. They exist as probability waves spread out over space. When a particle encounters a barrier, say an electron trying to pass through an insulator, there is a tiny probability that the particle will appear on the other side of the barrier without ever having traveled through it. It tunnels through. Now, here is where it gets weird. Experiments have shown that quantum tunneling seems to happen instantaneously. The particle appears on the other side of the barrier with zero time delay. Several experiments in the 1990s and early 2000s measured the tunneling time and found it to be consistent with zero, or even bizarrely, with the particle arriving before it should have if it had traveled at the speed of light. Is this faster than light travel? Does it violate relativity? No. And the reason why is subtle and beautiful. During quantum tunneling, the particle does not actually travel through the barrier in the classical sense. It is not moving from point A to point B through the intervening space. Instead, quantum mechanics describes the particle as having some probability of being on the other side. When you measure it and find it there, you have not witnessed faster than light travel. You have witnessed quantum probability collapsing. Moreover, You cannot use quantum tunneling to send information faster than light. The tunneling is probabilistic and random. You cannot control which particles tunnel and which do not in a way that would let you encode a message. In 2020, a team of physicists at the University of Toronto actually measured the time it takes for quantum tunneling to occur using sophisticated techniques involving attosecond pulses of light. An attosecond is a billionth of a second. They found that tunneling does take time. It is just incredibly fast. The time is related to the Heisenberg uncertainty principle, which says that there is a fundamental trade-off between knowing a particle has energy and knowing how long it exists in a particular state. The cosmic speed limit survives even this apparent challenge. Every time we think we found a loophole, nature shows us that the speed limit holds, but often in ways more subtle and beautiful than we imagined. Let me take you to the edge of known physics. There are hypothetical particles called tachyons that always move faster than light. These are not science fiction. They are serious theoretical constructs that appear in some physics equations. Here is the twist. If tachyons exist, they can never slow down to the speed of light or below. Just as it would take infinite energy to accelerate a massive particle to light speed, it would take infinite energy to slow a tachyon down to light speed. Light speed is an impenetrable barrier from both directions. The tachyon lives in a mirror universe where everything is backwards. From our perspective, tachyons would have imaginary mass multiplied by the square root of -1. They would lose energy as they accelerate and gain energy as they slow down, opposite to normal particles. And here is the really weird part. A tachyon moving faster than light would appear to move backward in time. If tachyons existed and could be controlled, they could be used to send messages to the past, creating all sorts of causality paradoxes, effects preceding their causes. Grandfather paradoxes, self-fulfilling prophecies. Most physicists believe tachyons do not exist precisely because they would create these paradoxes. The universe seems to protect causality fiercely. The cosmic speed limit is not just about speed. It is about protecting the logical structure of reality itself. In 2011, scientists at CERN made a shocking announcement. They had measured neutrinos traveling from CERN in Switzerland to the OPERA detector in Italy faster than light, about 60 nanoseconds faster than a photon would take to cover the same distance. If true, it would overturn everything we know about physics. The physics community was skeptical. Extraordinary claims require extraordinary evidence. Teams around the world worked to replicate the result. Eventually, the problem was found. A faulty fiber optic cable in the timing system, combined with a malfunctioning oscillator in the GPS system used to synchronize the clocks. When these errors were corrected, the neutrinos were found to travel at exactly the speed you would expect, just under the speed of light, accounting for their tiny mass. This episode is a perfect example of how science works. An extraordinary result was announced, skeptically examined, independently tested, and ultimately found to be an error. The cosmic speed limit held. But the fact that scientists took the possibility seriously shows something important. We do not hold the speed limit as a dogma. We hold it because every single test we have ever performed confirms it. The moment we find reliable evidence of something exceeding it, physics would have to change. But in over a century of testing, every challenge to the speed limit has failed. The universe is really, truly enforcing this rule. Now I want to bring this full circle and talk about something that connects everything we have discussed. Why the speed of light is the same for everyone regardless of how they are moving. This seems impossible. If you are chasing a beam of light at 99% the speed of light, should not the light only be moving away from you at 1% the speed of light? How can it still be moving at c relative to you? The answer is that space and time adjust themselves to keep the speed of light constant for all observers. When you are moving fast, space contracts in the direction of your motion, and time dilates. These effects precisely compensate so that light still travels at c from your perspective. Let me give you a concrete example. Imagine two spaceships passing each other, moving in opposite directions at 90% the speed of light each. You would think they are moving at 180% the speed of light relative to each other, right? Wrong. Due to the way velocities add in relativity, they are actually moving at about 99.4% the speed of light relative to each other. You can never add velocities in a way that exceeds the speed of light. The formula for adding velocities in special relativity is v equals v, 1 plus v2 over 1 plus v, 1 times v2 over c squared. For slow speeds, the denominator is basically 1, so you get v approximately equals v, 1 plus v2, regular addition. But as speeds approach light speed, the denominator grows, preventing the sum from ever exceeding c. This is not a trick of perception. This is reality itself, behaving in a way that protects the cosmic speed limit. Space and time are flexible. The speed of light is not. Here is an experiment that proves this beyond any doubt. Particle accelerators create particles through collisions, and these particles often decay into other particles moving in opposite directions. We can measure the speeds of these decay products, even when two particles are created moving in opposite directions at, say, 99.9% the speed of light each. When we calculate their relative velocity, it never exceeds c. The universe conspires to protect the speed limit through the elasticity of space and time themselves. Let me share something personal now. Something that changed how I see reality forever. When I first truly understood that the speed of light is finite, that when I look at the stars, I am seeing the past, it fundamentally altered my sense of now. There is no universal now. The present moment is not a single slice through time that extends across the entire universe. Now on Earth and now on a distant star are different things separated by light travel time. When you look at the Andromeda Galaxy, our nearest major galactic neighbor, you are seeing it as it was 2.5 million years ago. The light left Andromeda when our ancestors were Australopithecus, barely recognizable as human. That light has been traveling through space for longer than our species has existed, and it is arriving in your eye right now. What is happening in Andromeda now, at this very moment as you read this sentence? The question is literally meaningless. There is no now in Andromeda that corresponds to your now on Earth because of relativity. Different observers moving at different velocities would disagree about which moment in Andromeda is simultaneous with this moment on Earth. Your now is not universal. It is local. It extends only as far as your light cone, the region of spacetime that can be causally connected to you given the finite speed of light. This means the universe does not exist all at once. It exists in a complex web of causal relationships, with the speed of light determining which events can affect which other events. Think about that for a moment. Really think about it. The universe is not a static 4D block where past, present, and future all exist simultaneously. It is a dynamic, evolving structure where causality propagates at the speed of light, creating the flow of time itself. You are not living at a single moment. You are living in a region of space-time. And that region is defined by the finite speed of light. Here is something that is going to tie together everything we have discussed and show you why the speed limit matters on a cosmic scale. Black holes. A black hole is a region of space-time where gravity is so intense that the escape velocity exceeds the speed of light. Since nothing can exceed the speed of light, nothing can escape. Not matter, not light, not information. The boundary of a black hole, the point of no return, is called the event horizon. It is called that because events that occur inside the horizon cannot send light signals to the outside. They are causally disconnected from the rest of the universe. Here is what is profound. Black holes exist only because the speed of light is finite. If there were no cosmic speed limit, there would be no black holes. No matter how strong the gravity, you could theoretically escape by going fast enough. The event horizon of a black hole is where space is falling inward at the speed of light. At the horizon, space itself is moving inward at c. Inside the horizon, space is falling faster than c. Since you cannot move faster than light relative to space, and space is falling faster than light into the singularity, you cannot escape. Think of it like being on a treadmill that is moving faster than you can run. No matter how fast you run forward, you are still moving backward relative to the ground because the treadmill is moving backward faster than you are moving forward. In 1974, Stephen Hawking discovered something shocking. Black holes are not perfectly black. They emit radiation due to quantum effects near the event horizon. This Hawking radiation means black holes slowly evaporate, losing mass over time. Here is what is remarkable. Hawking radiation travels at the speed of light. It is the only thing that escapes from near a black hole, and it does so at exactly the cosmic speed limit. The speed of light is literally the boundary between what can exist in our universe and what cannot. Black holes are cosmic laboratories for studying the speed of light and its consequences. In 2019, the Event Horizon Telescope collaboration released the first ever image of a black hole, or rather, of the shadow cast by the event horizon against the glowing material falling into it. The black hole is in galaxy M87, about 55 million light-years away, and its event horizon is about 40 billion kilometers across. That image showed something profound. A bright ring of light surrounding a dark circle. The ring is light from material orbiting the black hole at nearly the speed of light. Some photons are bent around the black hole by gravity, creating the ring. Others fall in and are lost forever. The bright ring and dark shadow are determined entirely by the interplay of gravity and the cosmic speed limit. The universe has structure, has things like black holes, like event horizons, like causality itself, because the speed of light is finite. Let me share with you one of the most beautiful consequences of the finite speed of light: the cosmic microwave background. About 380,000 years after the Big Bang, the universe cooled enough that electrons and protons could combine to form neutral hydrogen atoms. Before this moment, the universe was opaque, filled with a hot plasma that scattered light constantly. After this moment, the universe became transparent. Light could travel freely. The photons that were released at that moment have been traveling through space ever since. As the universe expanded, those photons were stretched to longer wavelengths, cooling from visible light to microwaves. Today, those photons surround us on all sides, a faint microwave glow coming from every direction of the sky. This is the cosmic microwave background, CMB, discovered accidentally in 1964 by Arno Penzias and Robert Wilson, who won the Nobel Prize for the discovery in 1978. Here is what is profound. The CMB is a baby picture of the universe. When you detect CMB photons, you are seeing light that has been traveling for 13.8 billion years. You are seeing the universe as it was 380,000 years after the Big Bang. But here is the twist. Those photons left their source 13.8 billion years ago from our perspective. But from the photon's perspective, no time has passed at all. Remember, photons do not experience time. The moment of the photon's creation and the moment it enters your eye are the same moment for the photon. Every photon of the CMB is simultaneously experiencing the birth of the universe, and your retina right now. Past and present collapse into a single moment. For light itself, the finite speed of light allows us to be cosmic archaeologists. We can see the past by looking at distant objects. The farther we look in space, the further back in time we see. The speed limit is not a restriction. It is a window into history. In 2013, the Planck satellite released the most detailed map ever of the cosmic microwave background. That map shows tiny fluctuations in temperature, regions that were slightly hotter and slightly cooler in the early universe. Those fluctuations were the seeds of everything. Galaxies, stars, planets. You. The structures you see in that map, the patterns of temperature variation, are the ancestors of the atoms in your body. Those fluctuations grew under the influence of gravity over billions of years, eventually forming galaxies, stars that created heavy elements, planets where those elements could combine, and life that evolved to consciousness. You are descended from patterns in the cosmic microwave background. Your existence is encoded in light that has been traveling since the beginning of time. Now, I need to tell you about something that is going to sound like fantasy, but is absolutely real. The universe has a horizon. There is a limit to what we can ever see, no matter how good our telescopes become. This limit exists because of two factors: the finite speed of light and the finite age of the universe. Light from objects more than about 46.5 billion light-years away has not had time to reach us yet. The universe is only 13.8 billion years old. But because space has been expanding during the time that light has been traveling, the most distant objects we can see are now about 46.5 billion light-years away. Beyond that distance is, well, we do not know. There might be infinitely more universe beyond our horizon. There might be other structures, other clusters of galaxies extending forever, or the universe might be finite, curving back on itself. We cannot know because we cannot see beyond the horizon. The cosmic speed limit creates a fundamental limit on human knowledge. There are things we can never know, places we can never see. Not because we lack the technology, but because the information cannot reach us. The universe is hiding itself from us through the conspiracy of finite light speed and cosmic expansion. And it gets worse because the expansion is accelerating. The observable universe is actually shrinking. Right now, we can see galaxies 46.5 billion light-years away. But those galaxies are receding from us faster than light because of the expansion of space. The light being emitted from them right now will never reach us. We are seeing their past, but we will never see their future. Eventually, trillions of years from now, every galaxy except those in our local gravitationally bound group will have receded beyond the horizon. Future astronomers will look out and see only their own galaxy. They will have no evidence of the Big Bang, no evidence of dark energy, no evidence of the expanding universe. The cosmos will hide its own history. The finite speed of light creates not just a spatial horizon, but a temporal one. There is a limit to how far back in time we can see, the surface of last scattering where the CMB was released. And there is a limit to how far forward in time light from distant galaxies can reach us. We live in a special time, perhaps the only time when the universe's full history and structure are visible. Before now, the universe was too young and hot to see far. After now, the universe will have expanded too much to see far. We exist in a cosmic window of opportunity. You are living at a moment in cosmic history when the universe can be understood. That is not a coincidence. It might be a requirement for consciousness to exist at all. Let me now tell you about one of the most active areas of modern physics research: the search for variations in the speed of light. What if the speed of light is not actually constant? What if it was different in the early universe? What if it varies in the presence of strong gravitational fields? What if it changes over cosmic time? These are not idle questions. Several theories of quantum gravity, attempts to unite quantum mechanics and general relativity, predict tiny variations in the speed of light under extreme conditions. The effects would be incredibly small, but modern instruments might be able to detect them. In 2016, astronomers used observations of gamma-ray bursts, the most powerful explosions in the universe since the Big Bang, to test whether high-energy photons and low-energy photons travel at exactly the same speed. Some quantum gravity theories predict that the vacuum of space might have a slight graininess at incredibly small scales, around the Planck length, about 10 to the negative 35 meters. And this graininess might affect high-energy photons differently than low-energy photons. The results? No difference detected to the limits of measurement, which are extraordinarily precise. All photons travel at exactly the same speed, regardless of energy. The cosmic speed limit holds to at least 1 part in a billion billion. But the search continues. Scientists are using increasingly sensitive instruments to look for any hint of variation. Why? Because if we found that the speed of light varies, it would be a revolution in physics comparable to the discovery of relativity itself. It would mean our understanding of spacetime at the fundamental level is incomplete. Every negative result strengthens the case that the speed of light is truly a fundamental constant. But science remains open to evidence. We keep testing because that is what science does. It questions even its most cherished principles. Here is something I find deeply moving. The finite speed of light means the universe is never truly alone with itself. Think about it. Right now, photons from the Big Bang are arriving at Earth. Photons from distant supernovae that exploded billions of years ago are just now reaching us. Photons from stars dying today will not reach distant galaxies for billions of years. The universe is constantly communicating with itself across space and time at the speed of light. Every photon is a message from the past to the future. The cosmic speed limit means these messages take time to be delivered, creating a rich temporal structure to the universe. If light were infinitely fast, everything would happen at once. The universe would be a single, eternal now. There would be no history, no stories, no evolution, no possibility of change or growth. The finite speed of light gives the universe a narrative structure. It allows there to be a history, a story being told across billions of years. You are part of that story. The atoms in your body were forged in stars that died billions of years ago. The light from those stars traveled across the galaxy at the cosmic speed limit. Some of those photons were absorbed by early Earth, driving photosynthesis, creating the oxygen you breathe. Other photons carried energy that helped form the chemical complexity that led to life. You exist because light travels at the speed it does, not faster, not slower. The cosmic speed limit is calibrated precisely to allow structures like stars, planets, and living things to exist. If the speed of light were much faster, the early universe would have smoothed out too quickly. Matter would not have clumped into galaxies and stars. If the speed of light were much slower, the universe would have collapsed before stars could form. The speed limit we observe is perhaps not coincidentally compatible with the existence of complexity and life. Let me share the final, most profound insight. The speed of light is the speed of reality itself. When physicists talk about the speed of light, we are not really talking about light. We are talking about the maximum speed at which cause can propagate to effect. We are talking about the speed at which reality updates itself. Light just happens to be the most obvious thing that travels at this speed because light has no mass. But the cosmic speed limit is more fundamental than light. It is the speed at which information can propagate. It is the speed at which changes in electromagnetic fields propagate. It is the speed at which gravitational waves travel. It is the speed at which the Higgs field, the field that gives particles mass, can communicate changes. In 2017, the LIGO and Virgo gravitational wave detectors observed gravitational waves from a neutron star collision. Almost immediately afterward, telescopes around the world detected a gamma ray burst from the same source. The gravitational waves and light arrived at Earth within 1.7 seconds of each other after traveling for 130 million years. This observation confirmed something profound. Gravitational waves, ripples in spacetime itself, travel at the speed of light. The cosmic speed limit is not just about light or electromagnetism. It is about spacetime. It is about the fundamental structure of reality. The speed of light is the heartbeat of the universe. It is the rate at which the cosmos processes information and evolves from one moment to the next. Every interaction, every particle collision, every quantum measurement propagates outward at this speed, creating an expanding sphere of influence. Your actions right now are propagating outward at the speed of light. When you move your hand, you create tiny disturbances in the electromagnetic field around you. Those disturbances travel outward as electromagnetic waves at the speed of light. Admittedly, they are incredibly weak, far too weak to measure. But they exist, they are real. You are constantly sending out electromagnetic ripples that travel at the speed of light, adding your small contribution to the symphony of fields and particles that make up reality. So let me bring this full circle and answer the question we started with. Light has no mass. So why is its speed limited? The answer is that the question has it backwards. The universe has a speed limit, a maximum rate at which causality can propagate. That limit is a fundamental property of space-time itself. This limit exists because space and time are not infinite and absolute. They are flexible and interrelated. The cosmic speed limit emerges from the structure of space-time. Light travels at this speed not because of anything about light, but because light has no mass. Having no mass means light automatically travels at the maximum speed the universe allows. Light is the universe's speed limit made visible. The speed limit exists to preserve causality, to maintain the logical structure of reality, to prevent the universe from collapsing into a single timeless point. The finite speed of light creates time, creates history, creates the possibility of change and evolution. You exist because the universe has this speed limit. Your consciousness is possible because information cannot travel infinitely fast. Your memories are real because the universe has a causal structure enforced by the cosmic speed limit. Every time you see a star, you are seeing the past, proof that the speed of light is finite. Every time you experience the flow of time, you are experiencing the consequence of the cosmic speed limit. Every thought in your brain, every heartbeat, every breath is orchestrated by electromagnetic forces that propagate at the speed of light. The question, why does light have a speed limit, is really asking, why does the universe have a speed limit? And the answer is because reality itself requires it. The universe is not infinitely fast because infinite speed would destroy the possibility of structure, causality, change, and existence itself. The speed of light, 299,792,458 meters per second, is the speed at which the universe thinks itself into being. And now you know that every time you turn on a flashlight, you are not just making light. You are witnessing the fundamental speed limit of reality itself. You are seeing causality in action. You are watching the universe update itself at the maximum possible rate. That photon leaving your flashlight will travel at exactly that speed. Not because it is trying to, not because something is pushing it, but because it is massless and free. And the universe itself dictates that massless, free things travel at the cosmic speed limit. You now understand something profound. The speed of light is not a quirk of photons. It is the heartbeat of existence. It is the rhythm at which reality dances. It is the tempo at which the cosmic symphony plays. And you, right now, are part of that symphony. Your existence is a consequence of the cosmic speed limit. You are made of atoms held together by electromagnetic forces propagating at the speed of light. Your thoughts are electrical signals cascading through neurons at speeds determined by the electromagnetic properties of matter. Properties that ultimately trace back to the cosmic speed limit. You are a pattern of information constantly updating, constantly changing at rates governed by the fundamental structure of spacetime. You are the universe experiencing itself, processing information at speeds limited by the cosmic speed limit. The next time someone asks you why light cannot go faster, tell them light is not slow. Light is as fast as reality allows anything to be. The real question is not, why cannot light go faster? The real question is, why does reality have a speed limit? And the answer is because without that limit, there would be no reality as we know it. No time, no causality, no structure, no life, no consciousness, no you. The speed of light is the speed of existence itself. And that should fill you with wonder, with awe, with a deep appreciation for the intricate, beautiful, perfectly calibrated structure of the universe that allows you to exist and contemplate these questions. Before you go, I want to hear from you. Did this change how you see reality? Drop a comment. I read everyone. And if your mind is blown right now, share this video with someone else who needs their understanding of the universe completely reconstructed. Hit that like button if you made it this far. Because honestly, you have just completed a journey through some of the deepest physics in the universe. And remember, every photon you will ever see is traveling at the maximum speed the universe allows. The speed of light is not light's speed limit. It is reality's speed limit. Light is just the messenger showing us the fundamental law. Thanks for going on this journey with me. Until next time, keep looking up, keep questioning, and never stop wondering about the magnificent, mysterious, perfectly calibrated universe we call home.